welcome back to the lecture number 7 of chapter number 8. In the previous lecture, lecture 6, we have discussed about the second type of quadrilateral, which is known as kite. Okay. So what is a kite? A kite is a quadrilateral in which part the two consecutive pair of sides are equal. Okay. What is the third property? The third property is that out of the two diagonal, okay, one diagonal, this diagonal is bisected by this diagonal. Okay, so this is equal to this. Understood? Then fourth property is that, what is the fourth property? It tells you that AC and BD intersect at the point of intersection. Now this point of intersection, at this point of intersection, AC is perpendicular to BD. Okay, so this angle is 90 degrees. So AC is known as the perpendicular bisector of BD. And last and foremost property is AC also bisects the two opposite vertical angle. This is equal to this and this is equal to this. This is the property of kite that we have discussed. Now a question arises here that can a kite be a parallelogram? Tell me, can we call a kite to be a parallelogram? When we call a figure to be a parallelogram, if that figure satisfies all the three compulsory properties of a parallelogram that we have discussed. We have discussed three compulsory properties. What are the three compulsory properties? First property is that it must be a quadrilateral, isn't it? The second property is opposite sides are equal. The third property, compulsory property of parallelogram is the opposite sides are parallel. Okay, but does this kite follow all the three properties? Let's understand. Yes, it is a quadrilateral. It follows the first property. Coming to the second property. Here, for case of kite, does opposite sides are equal? Does you can write BC is equal to AD? No. We can't write. Does we write that BC is parallel to AD? No, they are not parallel. So, a kite does not follow all the three compulsory property of a parallelogram. That's why a kite can never be a parallelogram. Okay, you have to write this note. A kite cannot be a kite cannot be a parallelogram. We can't say kite to be a parallelogram. Okay. Second question arises. Can we call a parallelogram to be a kite? We know that a kite cannot be a parallelogram, but can we call a parallelogram to be a kite? No, because the parallelogram does not follow all the property of a kite. In case of kite, the consecutive sides are equal, but in case of parallelogram, this side and this side are not equal. No, they are not equal. So, parallelogram is not also a kite. Kite is not also parallelogram, and parallelogram is not also a kite. Okay. So you can write it. Similarly, a parallelogram can never be a kite. Okay. This is the most important concept you have to remember. Okay. So now let us understand the third type of quadrilateral, which is known as rectangle. Okay. So as you already know, what is a rectangle in some previous classes? Okay. So first of all, a rectangle is a quadrilateral, right? Like this. This is the figure of a rectangle. A, B, C. It has four sides. So this is the first foremost properties of a rectangle. So write down the properties of rectangle. Properties. So first property is it must be a quadrilateral. It must be a quadrilateral. So here it is about the quadrilateral A, B, C, D. Okay. Coming to the second property. The second property is that in case of a quadrilateral, in case of a rectangle, the two pair of opposite sides are equal. Okay. Here AD and BC are two opposite sides. Similarly, AB and DC are two opposite sides. And now these two opposite sides, this pair of opposite sides are equal. Okay? It means AD is equal to BC and AB is equal to DC. Right? So the second property you have to write it. The pair of opposite sides are equal. Okay? So in this figure we can write AD is equal to BC and AB is equal to DC. Clear? Next, third property. The third property states that the opposite sides are also parallel to each other. AD side and BC sides are opposite, so these two sides are parallel. Similarly, AB and DC are also opposite. That's why AB and DC are also parallel. So initially in the property 2 we have discussed what? That the pair of opposite sides are equal. But in third property we will discuss that the opposite pair of sides are also parallel. Right? So you can write the pair of opposite sides are parallel. Okay? So it means AD side is parallel to which side? This BC, because they are opposite sides, and AB is parallel to BC. Clear? So this is the third property. Coming to the fourth property. The fourth property is that the number of angle, how many number of angle does the quadrilateral has? It has 4 number of angles. Now the value of each angle for a rectangle is 90 degree. Okay, in case of rectangle, the value of each angle, angle A is 90, angle B is 90, angle C is 90, and angle D is also 90. Okay, so you can write value of each angle is 90 degree. It means for this figure A is equal to, B is equal to, C is equal to, D is equal to 90 degree. That is clear? So this fourth property are the most important property for a rectangle. Coming to the fifth property, what does fifth property state? It states that whenever we draw two diagonal of a rectangle, okay, let's draw two diagonal. AC is the first diagonal and BD is the second diagonal, isn't it? They both intersect each other at a point. That point is known as point of intersection, right? So here in case of a rectangle, the length of two diagonal are equal. It means AC is the first diagonal and BD is the second diagonal. Then these two's length are equal. If AC is 6 cm, then definitely BD must be 6 cm. Okay? So length of two diagonal must be equal. You can write it. Length of two diagonals are equal. Clear? So simply you can write AC is equal to BD. Okay? Next property. Property number 6. Now, these two diagonal AC and BD also bisect each other. It means AC bisect BD and BD bisect AC. Understood? It means this line, this diagonal AC bisect BD. It means this distance is equal to this distance. Okay. Similarly, BD line also bisect AC. It means this distance AO is equal to this distance CO. So both the diagonal bisect each other at the point of intersection. Okay. OC is equal to OA and OB is equal to OD. Right. So you can write the two diagonals bisects each other. Okay, so it means OA is equal to OC and OB is equal to OT. Right? Understood? But what do you know? We know that the length of AC and the length of BD are equal. Okay. So if we take half of this AC, then we will get AO. If we take half of BD, then we will get BO. Since AC and BD are equal, then their half must be equal. If AC is 6, BD is 6, then if we take half of it and half of it, we will get 3 here, here also we will get 3. So half of AC means AO, half of BD means either BO or DO. So you can write AO is equal to BO is equal to CO is equal to DO. Clear? So simply, instead of writing this, you can simply write AO is equal to BO is equal to CO is equal to DO. Okay, so this is the sixth property, which tells you that the two diagonals bisect each other at the point of intersection. Okay, but the most important property that you have to remind that both the diagonals do not meet each other at 90 degrees. That means the angle between this diagonal and this diagonal is not 90 degrees. No, but in case of kite we have discussed, but that the two diagonals bisect each other at 90 degrees. But here the angle between two diagonals is not 90 degrees. Okay, so you can write it in the property number 7. The angle between two diagonals is not 90 degrees. Okay, that is clear. The angle between two diagonals is not 90 degrees. Next property, last property, that is property number 8. What is property number 8? Property number 8 tells you that this diagonal and this diagonal bisect each other. We know it in some previous properties, and here the diagonal AC is not the angle bisector of A. It is not the angle bisector of A. It is also not the angle bisector of C. Similarly, the diagonal BD is not the angle bisector of B, is not the angle bisector of D. So simply, AC and BD are not the angle bisector of their respective opposite angles. Clear? AC is not the angle bisector of A. It is also not the angle bisector of C. BD is not the angle bisector of B and not the angle bisector of D. So you can write the two diagonals are not the angle bisector of their vertical opposite angles. Understood? So these are the 8 most important properties of a rectangle, and a quadrilateral must have to follow all these properties in order to be a rectangle. Okay, so let us summarize all these points at once. Okay, so in order to be rectangle, the first point is it must be a quadrilateral. The second point is the pair of opposite sides must be equal. It means AD is equal to BC and AB is equal to DC. The third point is the pair of opposite sides must be parallel. That means AD must be parallel to BC, AB must be parallel to DC. Fourth point is each angle must be 90 degree, right? Each angle must be 90 degree. Fifth point is the two diagonals AC and BD are of equal length, right? Next is property number 6. Okay, which tells you that whenever we draw these two diagonals, they meet each other at this point, and it is known as point of intersection. Now at this point, both bisected by each other. It means AC is bisected at the point O, AO is equal to CO, and BD is bisected at the point O, so that BO is equal to DO. Okay, sixth point. Coming to the seventh point. Seventh point is that the angle between these two diagonals is not 90 degree. No, here the angle is not 90 degree. No. And last point, but not the least point, is that any diagonal we draw do not bisect the vertical opposite angle. Okay, that means AC does not bisect angle A and angle C. BD does not bisect angle D and angle B. Okay, so these are the most important points. You have to remember it. Now, after this, a question arises. What is the question? Whether a parallelogram can be a rectangle or whether a rectangle can be a parallelogram. Okay, so let us discuss about this matter. Okay, so what is the question? First question is whether a parallelogram can be a rectangle. Okay, so in order to be a rectangle, a parallelogram has to follow some properties of rectangle, right? Okay, since though in the case of parallelogram, the opposite sides are equal, yes. The opposite sides are parallel, yes. But is the angle 90 degree in case of parallelogram? No, it is not 90 degree, right? That is why it can never be a rectangle. So a parallelogram can never be a rectangle. We can write it. Note: a parallelogram can never be a rectangle. Understood? Now our second question is, can a rectangle be a parallelogram? Is it true or false? Let's find out. So in order to be parallelogram, a rectangle must be follow all the compulsory properties of parallelogram. Yes or no? Yes. So what are the three basic properties of parallelogram? The first property is that it must be a quadrilateral, and rectangle is also a quadrilateral. So first property is satisfied. Second property, the pair of opposite sides of a parallelogram are equal. Here also opposite pair sides are equal. And the third property is that the pair of opposite side must be parallel. In case of parallelogram, here also as you can see in case of rectangle, the pair of opposite sides are also parallel. So what do we find? We find a rectangle follows all the three properties of a parallelogram. That's why every rectangle will be a parallelogram. Okay, we can write it down. Note 2. So every rectangle is a parallelogram, but the inverse is not true. Okay, inverse means we cannot say yes, all the parallelograms are rectangle. No. But every rectangle is parallelogram. Understood? Maybe the parallelograms, some parallelograms are rectangle, but not all the parallelograms are rectangle. Understood? So this is all about the properties of a rectangle. Understood? And in the next class we will discuss about another type of quadrilateral which is known as square.